Alright, so I added labels to the radio here. As you can see, it's white lettering for all the controls here. What I did was I used this label maker and I used a white on clear tape and then simply placed them on and they look quite good. So now the radio, now people know how to use the radio. Alright, I've added an instructional card right here. As you can see, it tells you how to use the radio, which is very handy because this radio relies on a function key right here and this tuning knob to set the memories and recall the memories and so on and so forth in the digital computer inside the radio. Alright, so I had to replace the audio, the speech amplifier here with this op amp because it was it was too sensitive. So this is a little more sane approach, and the radio is now acting very stable. Alright, now that I've changed to the BLF 647, I only need one driver and then one pre-driver stage because this amplifier is 20 decibels of gain. So due to some stability problems in my last PA signal chain, I've redesigned the power amplifier using a different transistor and completely changed the configuration. As you can see, we're using a BLF 645, which has about 20 decibels of gain, over 100 watts out on 10, maybe 60, 70 out on 6. That's because there is about a 1 or so dB roll-off between 10 and 6 meters on both the driver and the power amp as they are configured. So we're going to do a quick little demonstration. We're going to set up the spectrum analyzer to 20 megahertz per division. I still have to change the harmonic filters on this thing, but this should give you an idea as to how well it's working. So here we are with the microphone. Alright, let's key it up. N8ZRY, test, test, test. Alright, so getting a nice 115 out on that. So let's change bands here. Alright, band change complete. Do the same test. November 8 Zulu, radio, Yankee. Testing 1, 2, check 1, 2. Alright, so maybe 60, 70 watts out on 6, 115 on 10. So that's pretty good, especially something built in about 6 months of time. I think that kind of power level should do the trick. The next step here is on this redesign. As all difficult projects like this require redesign, I'm going to have to move the I'm going to have to mount the delay board and the Viswar protection board different places. I think I'll have to put the delay board, I think I might stick them on the side of the PA right here, and the Viswar protect board, I don't know, maybe I'll put that on the side too, and I think I'll remount the Viswar bridge inside of the harmonic filter box right here. So give you the next step there, but keep in mind this is quite literally just days before this radio is due, so this is last minute surgery, if you will. More later. Okay, so I had to redo the harmonic filters and adjust the bias for optimum harmonic suppression in both the driver and the power amplifier. So with the harmonic filters we're getting about 70 watts or so out. And you can see that's very clean for 10 meters. November 8 Zulu, radio Yankee, check 1, 2. Check 1, 2. Test 1, 2. November 8 Zulu, radio Yankee. So about 70 watts out, minus, let's see, minus 54 dB harmonic suppression. So we'll move on to build the 6 meter filter, which has to be extraordinarily severe because of the specs on that band. So we'll try to develop that one next. Alright, so here's the updated low-pass filter board, and I've also moved the reservoir protection unit onto it. So here we have the 6-meter low-pass filter, the 10-meter low-pass filter, and the switching relays. That goes to the receiver, this goes to the transmitter. There's the reservoir bridge, and the wiring out through these feeders. So I had to change the components in the 6-meter filter to higher Q to meet transmit spec. So we have air core inductors and high-frequency capacitors shown down there. Whereas the 10-meter filter it can use more conventional parts like these silver mica caps and those toroids. Okay, I've added this shield between the filter elements to reduce the higher frequency spurs as much as possible. Hopefully this will beat them down enough. Alright, so here is the completed radio, and we've corrected for all the instabilities. We're getting about 70 watts out on both bands, and the reservoir protection circuit works. And here's the inside. You can take a look at it. So we rearranged a few things. The PA is now 100% shielded. I migrated the reservoir protection board over here and the SWR bridge after the low-pass filters, and did some rewiring back here. The driver only is 1.5 watts. The PA has about maybe 18 decibels of gain, so you don't need that much drive power for it. And we'll take a look at the back. Okay, so here's the back of the radio, and you can see the shielded chassis there for the power amplifier. Otherwise, everything else is pretty much the same. There's the reservoir protection board, here's the low-pass filter, driver, and power amp. And the switch mode power supply is crammed in on the side over here. Alright, so here's the bottom of it, unchanged from before, except for the fact that I've added this speech amplifier that is more stable than using my audio power amp as a speech amplifier. This is the venerable 741. And we have two boards stacked there, so we have the receive audio board, then we've got the speech amp on top. Everything else is the same. Radio is operating very stable on the antenna, so well connected to the antenna. So next step will be to try the bottom of the radio. So it's all shielded, and we have this this ventilation down here, and you see the rubber feet. So this will help keep it cool. Okay, so here's the back of the radio once the cover's on, and then at the top after the cover's on. So there's a speaker right here, and of course lots of ventilation holes, so all the heat from the heatsink and the switch mode power supply and the driver will have no problem coming out of this thing. So hopefully that'll allow it to run nice and cool. Next thing we're going to do is try it out on the... Okay, so I repaired the CW side tone oscillator here. I had to improve it and build a new one. And you can see it right there. You can adjust the side tone by changing the... Okay, so I developed this new system low-pass filter. It's third order. And what we're trying to do is beat down the spurs at 100 megahertz, 200, and 250 megahertz. We're about 12 to 13 dB over. So right now we have the signal generator dialed into 250 megahertz, and as you can see, the attenuation of this amplifier is minus 51, 52 dB. Similarly for actually 200 megahertz, and actually pretty good attenuation for 100. So I think this add-on will solve the 6-meter spur problem.